In this video, I will discuss a JEE Advanced PYQ from the topic alternating current. First, I'll discuss some basics. Consider a resistor value R. When the potential difference V is applied across it, the current I will flow. The power dissipated in this resistor is I square R, and using Ohm's law, which states V equal to I into R, I can rewrite this as V square by R. With the potential of across this resistor, instead of representing as V, if I represent as delta V, then this power dissipated will be delta V square by R. Another basic thing that's used is, consider a transformer. There will be a coil on the input side, which is primary side. On the output side, secondary side. There will be voltage, say Vp, across the terminals of the primary coil. This will induce a voltage across the terminals of the secondary coil, say Vs. So the ratio of the voltage, the output voltage by the input voltage of the primary coil, is the transformer ratio, and it is equal to number of turns on the secondary side divided by number of turns on the primary side, number of turns of this coil. So if the number of turns is more, then there will be a voltage increase. So for a step-up transformer, Vs is greater than Vp. That means the number of turns on the secondary side is more compared to the primary side. And this can also be written as the current ratio, which will be the opposite, Ip by Is, because the input power, which is Vp, Ip, should be equal to the output power, that's Vs, Is. If the transformer is ideal, then there is no loss. If there is no loss, the power here will get transferred to the power on the output side. So using this, I can write Vs by Vp as Ip by Is. Another basic thing is, suppose I have an electrical device. The rating of the device will be given in terms of power and voltage. Say I have a device like this. So the rating of the device will be given in terms of watts, say X watts is the power rating, and the voltage is say Y voltage. The meaning of this is, if I apply a voltage of V across the terminals, then will consume a power of X watts. So from this, I can say that the current that will flow here, I, will be the power rating X by the voltage rating, because power is V into I, but the voltage Y. So this will be the current that is flowing here. For example, if I consider a bulb, say LED bulb, say 20 watts and say 220 volts, that means if I supply a voltage of 220 across the terminals of it, they will consume a power of 20 watts. In that case, the current here will be the power rating 20, which is V divided by V, 220, this many amps. So with this understanding, you can solve this JEE Advanced question. So this question has appeared in the year 2013. It's a paragraph-based question. Timestamps are given in the description box. You can watch parts of video if you're running short of time. This is the question. You can read it. A thermal power plant produces electrical power of 600 kilowatts at 4000 volts, which is to be transported to a place 20 kilometers away from the power plant for consumers' usage. It can be transferred either directly with a cable of large current carrying capacity or by using a combination of step-up and step-down transformers at the two ends. The drawback of direct transmission is large energy dissipation. In the method using transformers, the dissipation is much smaller. In this method, a step-up transformer is used at the plant side so that the current is reduced to a smaller value. At consumer's end, a step-down transformer is used to supply power to the consumers at the specified lower voltage. It is reasonable to assume that the power cable is purely resistive and the transformers are ideal with power factor unity. All currents and voltage mentioned are RMS values. This is a paragraph, and these are the two questions based on the paragraph. The first question: if the power transmission in the direct transmission method with a cable of resistance 0.4 ohm per kilometer is used, the power dissipation in percentage during the transmission is. 4 options are given. Second question: in the method using transformers, assuming that the ratio of the number of turns in the primary to that in the secondary in step-up transformer is 1:10. If the power to the consumers has to be supplied at 200 volts, the ratio of number of turns in the primary to that in the secondary in the step-down transformer is. 4 options are given. You can pause and up this question. It's a simple, straightforward question. So, first question: power dissipated in the transmission cable. So that is I square R, for I is the current flowing in the cable. So this current we can get from the power and voltage rating of the plant. That is 600 kilowatt by 4000 volts. So 600 K by 4000. So current is 600 K by 4000. It's 4 K square into the resistance is 0.4 ohms per kilometer, and the distance of the consumer is 20 kilometers from the plant. So resistance will be 0.4, that is per kilometer, and the distance is 20 kilometers. This is the total resistance of the cable. So this is 100, 27. So it will be 3. Another thing is we have to find the percentage dissipation. Percentage dissipation is this one divided by the power of the input plant, which is 600 K, 600 kilowatt. So it will be, okay, I can simplify this also. So it is 3 by 2 square into 10 raised to 4 into 8. This will become 4 into 2, which is 8. Okay, so 9 by 4 into 8 by input power is 600 kilowatt. And percentage means this is the fraction. To get percentage, you have to multiply by 100. So we go 2 times 3 2s are 6, 3 3s are. So a lot of things are cancelling. So 3 into 10 raised to, there is a K here. So 3 into 10 raised to 4. 2 will cancel. So 3 into 10 raised to 4 by 1000, so it's 30. So 30%. So option B is the correct answer. For 1, B is the correct option, 30%. So second part of the question, based on this paragraph. So this is a step-up transformer on the input side, and there is a transmission cable. Under the consumer end, there is a step-down transformer. So here the ratio is 1:10. So it's step-up voltage. And here we have to find the ratio NP:NS. So the planned voltage rating is 4000 volts, it's 4K. So here the voltage is 4K volts. So 10 times volts will be 40K kilovolts. That is the same voltage here. This drop will be negligible. So here also it's 40K volts. And at the consumer end, the voltage should be reduced to 200. So at this end, the voltage should be 200 volts. So the ratio is 200 by 40K. That will be equal to NS by NP. Voltage is proportional to the number of turns. So the voltage ratio is same as the turns ratio. Output by input is output by input turns. So we have to find primary to secondary. So we have to find NP by NS. This so it will be 2K by 10. We can cancel a 2 here. So 2K by 10, which is 200. K by 10 is 100. K is 1000. So 200 is to 1. So option A is correct for second question. First question, B is the correct answer. Second one, A is the correct answer. So this would explain here. You have to find the power dissipated in the cable, transmission cable. In the first case with I square R. I we can get from the rating of the plant, which is 600 kilowatt, and the voltage rating is 4000 volts. It's 4K. This is the current. The resistance of the cable is 0.4 ohms per kilometer, and the distance of the plant to the consumer is 20 kilometers. So this is the total resistance. So this is the total power dissipated. What you have to find is the percentage dissipation. So this we have the input power 600K into 100 in terms of percentage. That will be 30%. Second question, input side step-up transformer is 1:10 ratio. So this rating of the plant is 4 kilovolts. So here the voltage in the output side will be 40 kV. So that is the voltage in the transmission cable. On the consumer side, it should be reduced to 200 volts. So the ratio is 200 by 40K. That is the ratio on the secondary to the primary, which is 1 by 200. What you have to find out is NP by NS, which is 200 is to